Three things in the standard model are written down by hand and never explained. First, a scalar field added and tuned so that its vacuum value breaks the electroweak force and hands the W and the Z their weight. Nothing says why that scalar exists. Second, a lepton that weighs almost nothing, mixes almost maximally with its cousins, and maybe its own antiparticle. Nothing says which. Third, the wave law every fermion obeys, first order in space and time, simply declared. Three loose threads. This chapter takes all three to the same substrate and asks whether they are already tied. It is not that the theory computes their masses. It is that the theory does not have to import any of the three objects in the first place. Part 5 has already built a good deal of the standard model out of the substrate. Charge is a winding number. Mass is a lifted goldstone gap. The Coe-Day geometry is subspace equipartition, and the gauge group is selected by ANOMLE bookkeeping on a composite site. Three gaps were left standing, and they are exactly the three the opening named electroweak breaking, the neutrino, and the fermion spectrum. So, this is a triptych. 3 panels, 1 case each, and every one of them a former absent sector. And all three land on the same verdict: not solved, reduced. Reduced is a specific word here, and it is worth being precise about it. It does not mean solved. It means a sector has moved from one honest position to another. Before, the theory says nothing about this. After, the theory says this skeleton, forced by objects already in the corpus, and here is the single bounded calculation that would finish it. That is a much smaller claim than a derivation, and a much larger one than silence. Every verdict that follows carries that label. The ledger line at the end of the chapter uses the same word. Read it before quoting any of this as a prediction. One thing before we begin: Advaita Chakra Theory is a speculative exploratory framework, not established peer-reviewed physics. Much of what follows is honest conjecture that still needs validation. Watch it in that spirit as ideas to test, argue with, and refute. Before the panels, the suspects, the textbook moves this chapter declines to make. Suspect 1: add a Higgs doublet. The standard model posits a scalar and tunes its vacuum value until the symmetry breaks. On this substrate, a symmetry-breaking condensate already exists, guaranteed by the locking axiom. A second scalar would duplicate an object the theory is built on, so it is struck off as redundant, not as wrong. Suspect 2: a seesaw for neutrino lightness. The usual account makes it light with a heavy right-handed partner. Here smallness comes for free. From the weakest lock tooth of a ladder the theory already has, with no new heavy scale at the structural level. A seesaw may still organize the numbers. It is not the reason the neutrino is light. Suspect 3: postulate the Dirac equation. Writing the first-order wave law down by hand is what every textbook does. It works, and it explains nothing. The third panel replaces it with a theorem. Now the author's own corrections, 2 of them, because they change what this chapter is allowed to say. The first, an early reading, treated the half-angle spinner of chapter 20 as already establishing the fermion sector. It does not. It fixes the statistics and leaves the dynamics open. The second, an earlier draft, called the weak mixing angle, being a stiffness ratio a prediction. It is not a prediction. It is a reduction, because the ratio itself stays uncomputed until somebody diagonalizes the gauge mass matrix. Panel 1. The Higgs is asked to do 4 jobs. Hold a non-zero vacuum value that breaks the electroweak symmetry, give the fermions their mass, supply 1 physical scalar excitation, and donate 3 goldstone modes for the gauge bosons to eat. Now count what the substrate already has. The condensate amplitude is non-zero by axiom, so job 1 is done. The fermion gap is proportional to that amplitude by the mass mechanism of chapter 20, so job 2 is done. The physical scalar is the amplitude mode, the dilaton that plays the Newtonian lapse in part 3, so job 3 is done. And the 3 broken direction phase modes are precisely the would-be goldstones. 4 jobs, 1 object. There is nothing left for a separate scalar field to do. Then the breaking pattern, which is not chosen. It is read off the geometry. The on-site locking term pins every KY-RL parton channel to 1 common shaft. Under the electroweak group, that pinning survives along one direction only, the diagonal combination that leaves the shaft fixed, and that direction is not new either. It is the exact null vector the locking axiom already guarantees, the one exact zero mode of the whole substrate. So the electroweak group breaks to the electromagnetic one, and the surviving direction is that null vector. 3 generators broken. 3 phase modes eaten, 3 gauge modes gap, the W+, the W-, and the Z1 generator survives, so 1 gauge mode stays exactly massless. That is the photon. The massless photon of electroweak breaking is this theory's guaranteed gold stone. Now the numbers this panel does and does not deliver. Give each broken gauge mode a stiffness of coupling to the condensate. The Eaton Goldstone mechanism then gaps it. The gauge mass squared goes as the coupling squared times the condensate amplitude squared. That is Anderson-Higgs, spoken in the substrate's own language. The null direction has no broken generator to eat, so it stays exactly at 0 mass. The neutral modes mix into the Z and the photon, fixed by the ratio of 2 channel stiffnesses, which is the weak mixing angle. Its tangent is the root of the Hy per charge stiffness over the weak Ey iso-spin stiffness. So the angle is a substrate parameter, computable in principle from the coupling geometry, and not yet computed. The gap between those two words is the whole honesty of this chapter. Panel 1. Before we go on, the Higgs was asked to do 4 jobs, and the locking condensate already does all 4, so there is nothing left for a second scalar to be. The photon is the substrate's one guaranteed 0 mode. The weak angle is a stiffness ratio, and it is not yet computed. Panel 2. The neutrino needs no new machinery at all. It runs on rails already laid. Why is it light? Charged fermion masses here are lifted gold stone gaps, and the size of the lift is set by how strongly that channel is locked. A channel whose locking is near 0 has a near 0 gap. So the neutrino is simply the excitation of the least locked channel, and its mass goes as the square root of that channel's locking constant. No seesaw is invoked at the structural level. Smallness is the far end of the same clockwork ladder that already spans a factor of 3.4 times 10 to the 5th from the electron up to the top quark over some 18 teeth. The neutrino is the tooth with the weakest lock. Why is the neutrino its own antiparticle? This is the sharp one, and it turns on a topological fork. Charge is oriented winding, a whole number of turns of the phase around a defect. For a charged channel, winding and anti-winding are genuinely different configurations. Particle differs from antiparticle, and the fermion is Dirac. For the charged rho channel, there is no net winding to orient, so a defect can be its own anti-defect. An unoriented, real vortex, and a fermion equal to its own antiparticle, is what Majorana described. So the neutrino, being the excitation of the only charged 0 channel, is the only fermion whose defect can be self-conjugate. Notice how symmetric that is. The same winding integer that made the electron a Dirac particle also forbids it from being its own mirror image. And why does the neutrino mix so widely? The cyclic mass matrix of chapter 22 diagonalizes in a channel basis, and mixing between 2 sectors is just the misalignment of their bases. For quarks, misalignment was small, which is where the Cabibbo relation came from. For leptons, the mixing matrix is the charged lepton rotation against the neutrino rotation. Because that channel is barely locked, the entries of its matrix are comparable. The matrix is nearly democratic, so its eigenvectors sit far from the charged lepton basis, and the angles come out large. One sentence buys the headline of neutrino physics. Large lepton mixing against small quark mixing, because that matrix is nearly unlocked, hence nearly democratic. What is not delivered? The 3 angles, the masses, and the CP phase. Panel 3 opens on the honest retraction. Chapter 20, left standing. The half-angle Voartex spinner carries the right 2 pi sign flip. That is the statistics of a fermion, and it is real. But statistics is not dynamics. A spinner that transforms correctly is necessary, and it is not sufficient. What is actually needed is its equation of motion first order, chiral, with a mass term that is a gap, which sets up the awkward question: where does a first order wave law come from on a lattice whose own equations are second order? Declaring one is the move this chapter already declined, so the panel has to go in. The answer is a known theorem, not an open problem, and this is where the panel gets its spine. Volovich's result for helium-3a and for topological superfluids. Wherever a quasi-particle spectrum has an isolated node where the energy vanishes, and that node is protected by a topological invariant in momentum space, the low-energy expansion about it is forced to be linear and to take Weyl form. Not encouraged, forced. And out drops the Dirac operator, plus a tetrad read off the slope of the dispersion, plus an emergent gauge field from shifts of the node position, plus a mass appearing exactly when 2 opposite charged nodes merge and a gap opens. which is this theory's own mass mechanism, arriving from the other direction. This substrate is a natural host for that theorem, because it already carries both prerequisites. It has a complex order parameter, which supplies the particle and hole doubling, plus and minus winding. And it has a multi-channel dynamical matrix that is exactly a block Hamiltonian, the object whose nodes carry the invariant. The winding charge is already the bookkeeping the invariant uses. So the whole gap collapses to one computable question about the master dynamical matrix of the appendix. Does it have topologically protected Fermi points? The branch is clean. If yes, the Fermion sector is derived, and the number of nodes and the way they merge predict the Fermion mu-L triplet and its mass structure. If no, the Fermions stay a kinematic seed, and structure has to be added by hand. 3 panels, 3 verdicts. The Higgs scalar not needed, because the condensate already breaks the symmetry. The neutrino light because its channel is the least locked, and self-conjugate because a chargeless defect has no winding to orient. The Dirac equation not postulated but forced near a protected node if the node is there. All 3 now wait on the same calculation. The worked example, and note which way round it runs. The theory does not yet predict the weak mixing angle. It says the weak mixing angle is a channel stiffness ratio. So the honest exercise is the inverse one. Take the measured electroweak parameters and read off what the substrate ratio has to be. The measured pole masses are 80.4 GeV for the W and 91.2 for the Z. Their ratio is the cosine of the angle 0.8816. So the sine squared of the angle is 1 minus that squared 0.223, the familiar number. And the stiffness ratio is the tangent squared, 0.223 over 0.77, about 0.287. So the HY per charge channel is roughly a third as stiff as the Wiki-Wiso spin channel. Be exact about what that number is. It is a target for a coupling geometry calculation nobody has run. It is not an output of one. What this panel does stake a claim on is the custodial relation. Take the same measured masses, compute rho, the W mass squared, over the Z mass squared times the cosine squared of the angle, and it comes to 1.00 to the precision quoted. That is consistent with the locking geometry respecting a custodial symmetry. And it cuts both ways. A future substrate calculation that returned rho away from 1 at tree level would falsify the assumed Parton channel structure outright. One more piece of arithmetic, and it is the softest thing here, so I will label it before I do it. The same clockwork ladder can be asked to place the neutrino. The electron sits at about 5.1 times 10 to the 5th electron volts. A plausible neutrino mass is 5 times 10 to the minus 2. That is a factor of about 10 million. Let every tooth multiply the mass by the factor that carried the electron up to the top quark over 18 teeth, call it 2 per tooth. Then that factor takes roughly 23 further teeth, which is illustrative arithmetic and not a computed mass. Its only content is that the neutrino sits a couple of dozen teeth past the electron on the same ladder with no new mechanism. So what would break these panels? Prediction 1 is the sharp one. The neutrino is the charge 0 unoriented defect, therefore a Majorana fermion, therefore neutrinoless double beta decay happens. That is a genuine, near-term testable claim. A positive signal is consistent with the theory. A firm exclusion at the inverted hierarchy scale puts it under real pressure. And the prediction has a second edge that is easy to miss. No charged fermion may be Majorana here because its winding forbids self-conjugacy. So a would-be Majorana electron would falsify the winding account of charge outright. Prediction 2 is the custodial check we just computed. Tree-level rho equal to 1 is required of the locking geometry, and a substrate calculation returning anything else excludes the Parton channel structure. Its paired signature is already observed, large lepton mixing against small quark mixing, and that follows from near and locked, hence near democratic. Prediction 3 is the band topology fork. The dynamical matrix either has protected Fermi points, or it does not. A yes derives the Fermion multiplet and ties the generation count to the node count. A no demotes the fermions to a kinematic seed. Either way this is decidable and not a matter of taste, and the code is half written. The curvature check already diagonalizes the multiband dynamical matrix. The missing step is to sweep momentum across the Brillouin zone, find a node, and evaluate the invariant. That sweep is not in the corpus. Now the frontier, and there is something almost suspicious about the way it lands. 3 panels, 3 open ends, and one object closes all of them. The electroweak masses wait on the gauge mode mass matrix. The neutrino masses and angles wait on the channel structure. The Fermion multiplet waits on the node count. Every one of those three is downstream of the same calculation, the momentum space topology of the dynamical matrix, over the Brillouin zone. Evaluate the invariant at the isolated zeros, and you learn the node count, which is the generations. You learn the channel structure, which fixes the neutrino locking and the custodial check, and you learn whether the Dirac operator is derived or merely seeded. So the single object that would close this chapter is not 3 objects. It is 1. With one condition attached, and it is the crux. A bosonic rotor lattice has to carry the odd invariant, a genuine fermionic zero mode, rather than an even, unprotected crossing. That parity question is not assumed anywhere here, and a residue survives even a positive answer. The absolute electroweak scale, the locking strength times the condensate amplitude squared, is an input. Part 7 tracks it, next to the fine structure constant and the color count. Meanwhile, all 3 panels lean on chapter 25's, Parton construction, which is itself asserted. None of the 3 is firmer than that. Flagged here, not hidden. Calling any of them closed would overclaim. They are reductions from absent to one specified calculation. The verdict, in 3 parts, each with its own scope. 1. No separate Higgs field is needed. The locking condensate already does all 4 of the Higgs jobs. And the massless photon left over from the breaking is the substrate's own guaranteed zero mode. That much is structural, and that much is settled. 2. The neutrino is light because its channel is barely locked. It mixes widely because a barely locked matrix is nearly democratic. And it can be its own antiparticle because a charge zero defect has no orientation to reverse. The first 2 are relabellings. The third is a falsifiable claim with an experiment attached to it. 3. The wave law is not postulated. It is inherited from a protected node in the band structure, provided the invariant is non-zero. And whether it is, nobody has yet computed. The motif, one last time, one substrate, one gold stone worn 3 ways. The photon is that zero mode, unlifted. The electron's mass is that same zero mode, lifted. And the neutrino is that zero mode, barely lifted and left uncharged. Each panel has a laboratory twin as well, the quickest check that none of this is exotic. Electroweak breaking is a superconductor read backwards. The Majorana neutrino is a Kittive chain zero mode. And the missing fermions are the Fermi points of helium-3a and of vile semimetals. All 3 verdicts go forward into the Part 7 honesty ledger, where the shared residue is confronted and the one unblocking calculation is ranked. Until then, here is one to try. From the W and Z masses alone, reproduce the weak angle and the substrate stiffness ratio behind it. A word of acknowledgement. This work was inspired in part by the non-dual teachings of Sri Narayana Guru that the creator, the creation, and the substance of creation are fundamentally one. Symbols from the Hindu tradition, the Sudarshan chakra and the Shiva linga, suggested the analogies behind the chakra model. They are acknowledged as philosophical and symbolic inspiration. The physics stands on its own. Thank you for watching. If this made you think, please like the video and subscribe. It genuinely helps this work reach the people who will argue with it properly. And do leave a comment, tell me where you think I am wrong. Every chapter in this series names its own kill tests, and the objections are the point. Next chapter, Part 6 opens, and with it the experiment. This whole picture has to survive the double slit, not as a mystery, but as a theorem or else. The book and the next chapter are linked below. Until then, one substance and how far it reaches.